Now the next question is, if delta 1 is equals to 1 1 1 x square y square z square x y z and delta 2 is equals to this, then without expanding we have to prove that delta 1 is equals to delta 2. Now let's take this value delta 2 as, operate C1 as xc1, c2 as yc2 and c3 as zc3. Multiply column 1 by x, column 2 by y and column 3 by z. Because we are multiplying the columns, so we will have to divide this determinant by x, y, z. So x, y, z, x square, y, x, y, z, y square, z, x, y, z, z square. Now take x, y, z common from the second row. So x, y, z upon x, y, z, x, y, z, 1, 1, 1, x square, y square and z square. Now interchange first and second row. When we are interchanging two rows or columns, then we have multiply negative sign here. So it is 1, 1, 1, x, y, z, x square, y square, z square. Now here we have interchange row 1 and row 2. Now interchange row 2 and row 3. When we are again interchanging two rows or columns, then again negative sign here. So minus minus plus. So it becomes 1, 1, 1, x square, y square, z square, x, y, z, that is delta 1. So delta 2 is equals to delta 1. Note it down. The next one is, question number 14. If delta 1 is equals to A, B, C, X, Y, Z, P, Q, R, and delta 2 is Q minus B, Y, minus P, A minus X, R minus C, and Z. Without expanding or evaluating delta 1 and delta 2, show that delta 1 plus delta 2 is 0. Take this value delta 2. First, take negative sign common from second row. So it becomes Q minus BY, P minus AX, R minus C, Z. Now take negative common from second column. So minus minus plus Q, B, Y, P, A, X, R, C and Z. Now, what to do in the next step? Interchange rows and columns. So it becomes, now interchange row and column. So column becomes row Q, P, R, B, A, C, Y, X, Z. Now here we have the term ABC, XYZ and PQR. Now interchange C2 and C1. Column 2 and column 1 को interchange करेंगे. So PQR, ABC, XYZ. Now on the first we have the term ABC. So interchange two rows. When we are interchanging two rows, then the negative sign so it becomes minus A B C P Q R X Y Z minus A B C after interchanging two rows. Now interchange R2 and R3. Interchange R2 and R3. When we have interchanged two columns, then there is a negative sign. When we interchange then two rows, so negative, negative plus. Again we interchange two rows, so negative. So delta 2 is equals to minus of delta 1. So delta 2 is equals to negative of delta 1. That is delta 1 plus delta 2 is 0. Now the next one is question number 15. Without expanding, prove that A plus bx, C plus dx, P plus qx, Ax plus P, Cx plus D, Px plus Q, U, V, W is equals to 1 minus x square A, C, P, B, D, Q, U, V and W. Without expanding, prove that this. Now first operate R1 as R1 minus x R2. We want the term 1 minus x square. So we will have to multiply this by x and then subtract. R1 minus x R2. R1 minus x R2. R1 minus x R2. Next is Ax plus B, U, Cx plus D, V, Px plus Q, W. Now what we have left with here, by taking C common, 1 minus x square, dx will get cancelled, qx will get cancelled and dx will get cancelled. So in the next step, A into 1 minus x square, C into 1 minus x square and P into 1 minus x square. Now 1 minus x square is common. Take 1 minus x square common from R1. Take 1 minus x square common. We are left with A, C, P, Ax plus B, That is, this is what we want to prove. Now next question is, question number 16. Prove that minus a square ab ac ba minus b square bc ac bc minus c square is equals to 4a square b square c square. Now from row R1 we can take A common, from row R2 we can take B common, and from R3 we can take C common. So take ABC common from R1, R2 and R3, minus A, B, C, B common and C common. After this, now we can take A common from column C1, B from column C2 and C from column C3. So after taking this common, minus 1, 1, 1, 1, minus 1, 1, 1, 1 and minus 1. Now operate C2 as C2 plus C3 and C1 as C1 plus C3. C1 plus C3 minus 1 plus 1 0, 1 plus 1 2, 1 minus 1 0. C2 plus C3 1 plus 1 minus 1 plus 1, 1 plus minus 1. Now expand it without. Now find the value of this. We can expand it along this column because it has maximum number of zeros. A square, B square, Z square. 0 into something 0. Next term is minus 2 into second row and second column. 0, 0, 1, minus 1, minus 0 into something. So A square, B square, C square plus, or we can take 2 common. We can do by this method also. Take 2 common from both the columns. 2 into 2, 4. A square, B square, C square. 0, 1, 0, 1, 0, 0, 1, 1 and minus 1. Now expand it. 4A square, B square, C square. 0 plus 1 into 0 minus 1 into 1 0 1 minus 1 plus 1 into 1 0 0 0. So 4A square B square C square minus 1 minus 1 minus 1 minus 0 0 minus 0. So minus minus plus 1. So 4A square B square C square into 1 is 4A square B square C square. Note it down. Next one is question number x into y. Prove that this. Now operate C2 as C2 minus C1 and C3 as C3 minus C1. C2 minus C1, 1 minus 1. Here we are left with x, 1 minus 1. Now expand it along the first row, 1 into x 0 0 y. Next terms are zeros. So 1 into xy minus 0, so that is xy. Next is question number 18. Evaluate 1 1 1 a b c a square b square c square. Now in this type of question, what we have to do, operate r2 minus r1 and r3 minus r1. R2 as R2 minus R1, R3 as R3 minus R1. 1a square, operate R2, 1 minus 1, b minus a, b square minus a square. 1 minus 1, c minus a, c square minus a square. Now take b minus a common from R2 and c minus a common from R3. B minus a, c minus a. 1a square. B minus a is common. A square minus b square have formula a minus b, a plus b. So here we have left with b plus a. 0, 1, c plus a. 0, 1, c plus a. Now in the next step, operate R3 as R3 minus R2. Zero minus 0, 1 minus 0, A will get cancelled, C minus B. Now take C minus B common from here. A square, 0, 1, b plus a, 0, 0, 1. Now, first column has maximum number of zeros, so expand it along the first column. B minus a, c minus a, c minus b. 1 into 1, 0, b plus a, 1. Next two terms will be 0. So b minus a, c minus a, c minus b, 1 minus 0. Take negative common, we can write it a minus b. This is b minus c and c minus a. So the answer is a minus b, b minus c, c minus a. Next one is question number 19. Show that determinant of x, y, z, x square, y square, z square, x cube, y cube, z cube, that is equal to x, y, z z from C3. So take x, y, z common. Now in the next step, operate C2 as C2. We want y, x minus y or y minus z. So x minus y. So operate C1 as C1 minus C2. Y minus z we want, so C2 as C3 as C3 as C3 minus C2. So